Hi there, today we're going to do a short lesson on decimals. And I like to say that decimals are fancy fractions. And what I mean by that is that decimals are fractions with a denominator of 10, 100, or 1,000. And our place value number system can extend where we know with ones, tens, hundreds that we have parts of a whole, and when we have a denominator of 10 and 100, this place value is called tenths, and this place value is called hundredths. And then the next one we'll have is thousandths. But right now we're going to focus on tenths and hundredths. So looking at these grids, if we know that if we're going to call this grid to represent one, the number one or one whole, then dividing it up into 10 equal parts will give us units called tenths. So we could call this 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. So 10/10 is equal to one whole. And then these bottom visual grids are equal to 100 equal parts. So if I were to shade in 1, that unit is called 1/100th of a whole because it's one piece, and in word form we would call that 1/100th with a TH on the end. So we can see right here, if I wanted to shade in 1/10, I would call that fraction form 1/10 or decimal form 0.1, meaning 0 wholes and 1/10. This number here, I would need to put in a 0 in the tenths place and a 1 in the hundredths place. So if we were to go back to our place value chart, that first value would be 0 whole squares shaded in and 1/10 for our first visual model. And then our second visual model would be written as 0/10 shaded in because we do not have any of the long sections called tenths, and 1/100th, so 1 square. On the hundredths grid, there are 100 equal parts. If we were to count these, we would find that there are 100. So now we're going to practice writing some decimal numbers. So if I were to represent the number 27/100ths and the number 7/10ths, in word form that would be 7/10ths and 27/100ths. And if we were comparing these values, I want you to think about which one you think is greater. A lot of students will think it's 27/100ths because they think of whole numbers. 27 is more than 7. But we have to remember that tenths are 10 times greater than hundredths. And what that means is it takes 10 of these tenths to be equal to 10 hundredths to be equal to 1/10. So if I shade in 10 of those, I would write that as 10 hundredths. And that is an equivalent decimal to, see how it's the same part of a whole shaded? So we can say they're equivalent decimals. So 1/10 is equivalent to 10 hundredths on the hundredths grid. So it takes 10 of these to be exactly the same size. So because they're equivalent fractions, we can also say they're equivalent decimals. So 10 hundredths is how we read this one, and 1/10. So going back to our example, which one is greater? If I were to shade in 27 hundredths, I would go to the unit of hundredths and I would say 100th, 200th, 300th, count with me, 400ths, 500ths, 600ths, 700ths, 800ths, 900ths, 1000ths, which is the same as 1/10. 1100ths, 1200ths, 1300ths, 1400ths, 1500ths, 1600ths, 1700ths, 1800ths, 1900ths, 2000ths. So we would write that as a decimal as 0 and 20 hundredths, or 20 over 100 as a fraction. The denominator is tenths, hundredths, or thousands when we're talking about decimal numbers. So now I want you to think, how many tenths would that be equal to? So this would be 1/10, 2/10. So do you see how it's the same part of a whole shaded? So I can say that 2/10 is equivalent to 20 hundredths, because these hundredths, it takes 10 of them to equal 1/10. And then we can write that they're equivalent fractions, that 2/10 is equivalent to 20 hundredths. Now, to go back to compare which would be more shaded in, 27 hundredths or 7/10. So I'm going to go ahead and shade in my 7 more hundredths. And then what do you notice? Hopefully you'll notice that less than half of the squares are shaded in. So now we can say that this represents 2/10 and 700ths. So another way to think about this is this could be written as 2/10 plus 700ths. We call that expanded form. Or if your students are using Eureka Math, they might see it as 2 times 1/10. 2 groups of 1/10 plus 7 groups of 100th is a way to write that in expanded form. So the reason we can say that is because we know that these 10 hundredths, 20 hundredths is equivalent to 2/10. So we can rename it as 2/10. So now when we're thinking about what is greater or more, if I'm comparing 7/10 to 27 hundredths, I'm going to represent 7/10. So we had 2/10 shaded in, 3/10, 4/10, 5/10, 6/10, 7/10. So now, students, I want you to think about what is more shaded in. The top grid, 7/10 or 27 hundredths. So here we can show that 7/10 is greater than 27 hundredths. And we can also compare them vertically on a place value chart. When we line up our place values to compare them, we're going to compare values just like with whole numbers from left to right. This is the ones place, and both numbers have 0 holes shaded in. And now we're going to compare the amount of tenths, because we know it does not matter what's in the 700ths place. If we don't even have enough hundredths to create 3/10, then it does not, this shows us right here that 7/10 is greater than 2/10. So even though this number has 0 hundredths, we know that this number doesn't even have enough shaded in to have 3/10 shaded. Another way to think about it, so once again, that shows 7/10 is more than 27 hundredths. Another way to think about it is, can we turn 7/10 into hundredths? How many hundredths is equal to 7/10? I want you to think about that for 1 second. So I want to know 7/10 is equal to how many hundredths? So let's think about it as an equivalent fraction. I know that when I multiply the top or bottom by the same number, so I'm going to make 10 times as many pieces or parts in my whole. 10 times 10 is 100. And then I'm going to make 10 times as many parts shaded. So that would be 70 parts shaded that I have made equivalent fractions. So 7/10 would be equivalent to 70 hundredths. So up here in decimal form, I would read this as 70 hundredths and 7/10, and they are equivalent. So we can prove that. So here's our 70 7/10. So I'm going to draw lines across to decompose or partition or break apart. And I'm going to make 10 times as many pieces in my whole. So let's see, we had 10 equal parts. And if we divided each tenth into 10 equal parts, we make 10 times as many pieces. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 equal parts. So now my grid shows a denominator of 100. And if we were to go back and count how many are shaded, this would be 100th, 200ths, 300ths, 400ths, 500ths, 600ths, 700ths, 800ths, 900ths, 10 hundredths, which we know that 10 hundredths is equal to 1/10. So now if I had, this would be 20 hundredths, 30 hundredths, 40 hundredths, 50 hundredths, 60 hundredths, 70 hundredths. So our equivalent decimals would show that I have shaded in 70 hundredths, and that is equal to 7/10. 70 hundredths as a decimal, and it's equivalent to 7/10. It's the same part of a whole shaded, so we can write it as fractions and as decimals. So I want you to think about that. In your next step, I want you to figure out how would we say this number? And I want you to think, is that greater than or less than this number? So think about, that's your next step, to think about this decimal value versus this decimal value. Have a great day.